In this presentation, we are going to look at the exponential distribution. All these questions concern the time we need to wait before a given event occurs. If this waiting time is unknown, it is often appropriate to think of it as a random variable having an exponential distribution. Roughly speaking, the time we need to wait before an event occurs had an exponential distribution if the probability that the event occurs during a several time interval is proportional to the length of the time interval. The probability density function of the exponential distribution is equal to lambda e negative lambda x when x greater or equal to 0, otherwise is equal to 0. The parameter lambda is called wait parameter. It is the inverse of the expected duration. For example, if the expected duration is 5 minutes, then the wait parameter value is equal to 1 over 5, which is 0.2. The cumulative distribution function of the exponential distribution is equal to 1 minus e to the power negative lambda x when x greater or equal to 0, otherwise is equal to 0. This is the proof of the CDF. The moment generating function of the exponential distribution is equal to lambda over x minus t. The expected value of the exponential random variable x is equal to 1 over lambda. Also, the variance is equal to 1 over lambda squared. This is the proof of the moment generating function. It is noticed that the function of exponential random variable exists for all t less than lambda. For the part B, if you want to find out px greater than 10, you can just simply 1 minus px smaller than 10. Let's have an example. Assume that the length of the bus arrived at the bus stop in minutes is an exponential random variable x with parameter lambda equal to 1 over 5. If someone arrives at the bus stop just before you arrive, find the probability that you will have to wait. A. Less than 5 minutes. B. Greater than 10 minutes. C. Between 5 and 10 minutes. Also, you need to compute the expected value and variance. For the part A, it's quite simple. Just substitute lambda equal to 1 over 5 into the formula, and you can compute that the answer is equal to 0.6321. For part C, the probability being inside this interval is the complement of being outside the interval. So the required probability is equal to 1 minus 0.7674 is equal to 0.2326. The expected value and variance is just substitute the lambda into the formula, and you can calculate that the expected value is equal to 5 and the variance is equal to 25. So you can calculate that px greater than x is equal to e to the power negative lambda x. So substitute lambda equal to 1 over 5, you can calculate that 0.1353. The probability of being outside the interval is the composite event being too low for the interval and being too high for the interval. So if you want to calculate the required probability, you can just 1 minus px smaller than 5 and px greater than 10. Let's have an example. Assume that the length of the bus arrive at the bus stop in minutes is an exponential random variable x with parameter lambda equal to 1 over 5. If someone arrives at the bus stop just before you arrive, find the probability that you will have to wait. A. Less than 5 minutes. B. Greater than 10 minutes. C. Between 5 and 10 minutes. Also, you need to compute the expected value and variance.